Hello everyone, and welcome to another video where today I wanted to address what I guess is sort of a footnote on my second video in the iron mining and refining series, the one I made about the fuel. Now, a thought arose as I was working on quite a bit of chem homework, which is actually one of the main reasons why I can't go ahead and just make a fourth video in the series, because I'm up to my neck in work. But the bright side is that it made me think of something that's actually really important and pertinent to the series. Specifically, when dealing with the specific chemical reaction that we're working with here, it's iron oxide. I don't know. I think magnetite is like 3, maybe? I don't know. But iron oxide plus carbon monoxide turns into iron metal and CO2. Now, this is a horrible oversimplification, but you get the idea. The carbon monoxide is a gas, so it can react and move around quite a bit in the hot furnace, and it produces iron metal and CO2. Simple enough. How is this relevant to the fuel? Well, I was exploring alternative fuel sources because, well, this stuff is incredibly difficult to make. And, well, I was looking into it, and if you've already seen the second video, I outlined that I was going to try to just use coals from a fire. It's essentially the same stuff, except that's just hot and easier to make. I was also thinking, in that regard, if it's hot, one of the main issues with the furnace would be maybe it would get too hot. From my research, if you increase the temperature too much, then you get an issue where this happens way too much and you start getting iron associated with carbon, and then a little bit of that's good, but once you get too much of it, you start making cast iron, and that is not what you want to be doing. At that point, the process is basically a failure. So you need to have some way to cool it down, and I thought of two ways. The first one, and the one I'm definitely going to be using, is to just add more iron oxide. This is going to start at roughly room temperature, and it's going to be essentially a pile of rocks. So that should soak up a decent amount of heat, and if too much iron associated with carbon is made, then maybe it'll equalize. The second option, which I realized was an interestingly bad one, was, hey, this is just made when you heat wood in a fire, right? So what if, to cool it down, I just put some, raw material, just put some wood on the top of the fire and turn that into charcoal, and that process will lower the temperature. This would essentially do that to the reaction. And here's why. So charcoal is basically pure carbon. So it's just C plus O2 equals CO2. Good reaction. That's complete combustion. Incomplete combustion, which is what we want to get this, will produce C2 plus O2 is equal to 2 carbon monoxide. That's essentially what we want to be happening. Not too much, because, you don't want too much of this, but a little bit of this is what we need for the reaction to progress the way we want it to. However, wood is not just carbon. It's carbon plus hydrogen plus oxygen plus yada yada yada. This hydrogen's a problem, because when you burn something that has carbon and hydrogen, you get carbon plus H2. This is really bad technique, but you know what? Who cares? Plus O2. I know these don't add up, but you know what? 2. There we go. And then you get, goes to CO2 plus 2 H2O. Now, iron metal, when exposed to water at normal temperatures, oxidizes. It rusts. So you can imagine what will happen when superheated steam is introduced into the equation. It'll essentially turn the reaction around, and any iron that was made is going to get converted right back into iron oxide. This information is also very important because it means that I need to make sure that the fuel I use, whether it's charcoal like this or charcoal made in the way I would prefer, has as much hydrogen driven out of it as possible. Otherwise, the whole thing is ruined. Well, that's about it. Hope you guys learned something. See ya.